Hello everyone, this is Azure and today we're going to do some competitive programming with CSES problem set. So I've already opened all my apps that I will need for today. So I will try to solve lots of tasks from there, some of tasks from there, and like some interesting problems from CSES mainly. This is going to be interesting at the future it's possible that I will first code forces dealer, input dealer, at coder, hacker, and use Sacco, list, we judge, lead code, then I learned for competitive programming. Be honest, it's really interesting to study this, just being competitive, just studying, that's all. So mainly I don't have any template. I want just to do this without template. So let's get started. Let's for first time write some template. Let's so mainly I don't think so the first 5 tasks is going to be hard. Solve, yeah, that's good. So and also let's like this using ls long. Okay, so what's going on there? There are saying that consider an algorithm that takes as input as a positive integer n, if n is 7 divides it by 2, and if it's odd, multiply 3 plus 1. Yep. So this is one of the algorithms I have ever heard. What is this algorithm mainly? Yep, this white algorithm. Word solution. Name of algo that looks like this. Yep. The algorithm is officially known as Collett's conjecture. Okay, so let's also start this. Wait, known as a yeah, that's pretty interesting. Okay, so for a while, let's just try to do some of this. Then we just think about like yep, so I think so we just need to first print n to make some while loop. Yep, that's all. Let's see out n doing it by space. So yeah, oh my goodness. So, there, and then we just try to do this while n is bigger than 1. Just if n is divisible to 2, is divisible to 2, just see out some of type of wait a minute. Yep, divided to 2, and no, premised. Wait. I just do n divided to 2, and then I just see out. That's wrong. At the else point, I do this. Okay, let's just write it right now. Holy crap. It has lots of bugs. I think so. Nope, it's not. Let's just take input. Holy crap, I missed this input. It's 3. Okay. Let's just cat output out. Yeah, it's incredible. Let's submit this. I'm glad. Good point, good point. So right now let's move on next task. And we're given n. Okay, oh, this template task, we are given all numbers between yeah. Expect one, your task is to find the missing number. So this is one of the best tasks I have ever heard, because this task has three solutions, and I'm going, I think so, to say right now the main one. What is this? Mainly, firstly, let's copy this. Main one right there. Nope, I missed. So this task has only two solutions. How do I know? It's possible it also has lots of, but I'm going to say really the most interesting, and I hope I'm not lying. Okay, so for example, we have numbers. Yeah, for example, let's just use some default, and let's take some array, and it says expect one, so it means the array size is n minus 1. Let's take an input when after we took input, we have some to-do list. For example, how do I know? Let's just do like this. Yep. Okay, I'm missing. No. Right there. And this. Okay, I missed. So let's just delete this. Right there. So first and second and third solution. Oh, I mean steps. First step. Let's just analyze this. You are given all numbers between 1, 2, 3, 4, like to n. Expect one. Your task to find missing number. The first input contains an integer n, and the second line contains n minus 1 numbers. Yep, I missed this input. And then each number is distinct and between 1 and n inclusive. Print the missing number. 1, 2, 3, 4, 5. So we missed 4. First solution is just by easily, if we find the sum from 1 to 5, and we find the sum of array, and then we find the difference between sum from 1 to n and the sum of array, we get 4. From 1 to 5 it's how do I know, 6, 10, 15, yep, and 11 there, yep, and 15 minus 11 is 4. This is first solution, and let's firstly implement this. Mainly we just find some 1 n, find some array, and answer is equal to let's call it x, and call it y, and x minus y, and then yep, and we'll call it array. It's going to be sum. No, I missed. So this x, this y, well, y is equal to 0, y plus 1 e, and let's find x is equal to the, yeah, so for finding sum from 1 to n is I'm going to say this, just remember this for your rest of your life. If you're some scientist or something else, it's n multiply n plus 1 divided 2. Yep, so a little x is equal for n multiply n plus 1 divided 2. Let's do it like this, just for fun. See out x minus y let's compile our file, and I think so the input is ready. Yep, it's ready, we gave it already. So, and calculate output for this is first solution. Accepted. So back to task. There's technique max. I don't remember how it is translating max in competitive programming. Yep. Yep. Minimal excluded of a sequence, or often it's just some permutation. As you see there, 3, 5, and 0. Okay, so max is just skip number, and mainly minimum skip number. For example, our n is 5, and it includes 0, 1, 2, 3, 4, 5. 3, 4, 5, yeah. And if you skip some of them, and if you want to find, not find just, we have the technique max that finds the minimal excluded, and minimal excluded is also showed there, like, and minimal max is going on sorted array. Yeah, that's all, and mainly it translates as minimum excluded of a subsequence. Yeah, minimum, and there's x. Okay, I just don't care. So yeah, here's how it looks like. Mainly, there's also lots of types of algorithms for making max, mainly finding max. Yep, how will I say it? With arrive dates. Like some range queries. Interesting. Yep, this is really interesting technique that I prefer you to learn. It's helping me lots of times. Okay. Now we go to the task, and there we just can do some minimum excluded algorithm. That's all, and also we could use some map. For example, from 1 to 5. Yep, I have seen this first one time, one time, but at map I cannot see 4. Like if all case in order. Mainly it couldn't be if some k is not appearing, for example it's 0, then we print this k. That's all. So and yep, this was third solution I missed. Yep, there are 3 solutions. There are just tons of solutions. There's also 4th solution when you use some indexes, but I haven't learned about this. Okay, let's move on some third tasks. Good point, good point. You are given a DNA sequence, a string consisting of characters A, C, G, and T. Your task is to find the longest repetition in the sequence. This is maximum length substring containing only one type of character. Yup, I see you, man. So this, yeah, it's pretty easy. So just make some maximum and current. That's all. Let's move on there. Do you have n? Nope, it's good. Let's take it as an input. So okay, let's get started by hello, just some I don't remember how to do this algorithm. It's really hard. It's annoying algorithm, and let's take some string, take input for the string, and then we are going to do a little current is equal to 0 and answer is equal to 0. After this, let's try to implement this like this. It's less than, let's, no, I hate this. So I'm going to try with this size T. It's really good for finding and determining size of some sequences, some permutation, and others. Yep. It's going to be cool. Is that size? Or you mainly just can do like this. How would I know if I don't miss? I don't use this so much like this. But okay, I don't care mainly. So, and also we are going to start it by size T and less than n. After this, wait a minute. Yep, so I think that there could be -1, but I'm not hurrying up. Of course, answers go to the max. Holy crap, I don't remember this already. Yeah, there's going to be -1, and if SE is equal to the SE plus 1, like for next element. And here we do current plus plus, and answer is equal for the maximum of itself and current at the else position. Did we do anything? Nope. The else position, let's do it current is equal to 1. Yep, so it's on. Let's compile our file. Okay, I'm going to run this. It's 3, and let's try some of this. A just is going to give us 1, and I hope. Yeah, that's the point. So let's just do. What do I do like this? Nope. Mainly there are just one. It's automatically 1. What if I compile my file? I'm gonna press again Ctrl S. That's all. Then it's going to work. How do you know? Yep, 1. Could we give something another, like, let's try R1. Let's just B C C C D E F G T R. So mainly, how do I know? 1 2 3 4. Yup, 4 of them. That's all. Okay, let's try to cat our output. It's 4. Yep, that's what doing it. Let's submit this. It's our task. Yep. Submitting this, and I will get some accepted. Yep, I'm glad with this. Good point. Increasing array. Okay, so you are given an array of integers. You want to modify the array. Okay, let's clear this. You want to modify the array so that it's increasing. Every element is at least as large as the previous element. Wait a minute. Every element is at least as large as the previous element. Okay. On each move, you may increase the value of any element by 1. What's the minimum number of moves required? It's strange. On each move, you may increase the value of any element by 1. What is the minimum number of moves required? Oh, wait a minute, let me check. Is it like... Oh, holy crap. Oh, this is really boring task. Like, there I do -1 with absolute, I mean 2 minus 3 is -1, absolute value is 1, then 1 plus, yeah, 1 plus, then there's 3, no, it becomes 3, and then 5 minus 3 is 2, yep, then it's, no, it's increasing. Oh, I don't need to do this. Okay, so wait, it's increasing 3, 3, 5, then 1 minus 5 is -4, absolute value is 4, there are the plus 4, and middle is 5, yeah, no, yeah, we get 5, okay, I see the sense. Yep, so let's just solve this, and it's given a array after, yep, okay. Okay, so yeah, let's get started by how so okay, let's just do a little scope some default value, then I give some array. Okay, so after this I like to try wait a minute, so okay, right now we look at our array. Holy crap, what is this? And -1. Yep. Again, I don't think so that I don't need size 2, or I need this. Am I stupid, or what the hell? Okay, let's put it like this. So after this we just compare them. If we need to check if AE is larger than AE plus 1. Nope. Yep, I'm right. Yeah. Okay, so if, let's copy this just. Okay, so AE plus 1. Then I just want to make some answer variable. It's going to be equal for absolute value of AE plus 1. No, just okay. You could do AY minus 1, AY minus AY plus 1, and by absolute value. So let's just do this by absolute value. I'm used to like this, and AE. Yep. Then I give the value for AY plus 1, and its value is AE. That's all. That's the point, and then printing the value. Yep. So let's compile our file. I hope completion is going to be well. Yep, it is. Let's output 5. Yep, there also was 5. Let's submit our file. I think this is going to be good. What if I give 1 as an input? Like for 1, it's good question mainly. What about if I give 1? Just it means that we need to do 0 operations. Yeah, like 0. And I think so it is. Let's just run our file. Yep, it is. So let's just submit our code. Submitting this. Yeah, good point. permutations. What's this? Also there's number spiral. Oh no. Permutation of integers 1 to the n is called beautiful if there are no adjacent elements whose difference is 1. And n consider the beautiful permutation if such a permutation exists. Oh, I have yeah. I remember once I was solving this type task, and it's while I was doing this solution, it was so boring, but at the same time, it's really also interesting. Yeah, it also gives its solution at the output. It's constructive algorithm. First, I'm going to say what is constructive and what's constructive algorithm. So, constructive algorithm is when problem says you to make that type algorithm. For example, it says to make a beautiful permutation or something like this. And if task tries to say just make this type algorithm, it means this constructive algorithm, you know, like the tag of this task. I think it's also given there. It's not math, man, yo. Okay, so yeah. The next thing I'm going to say is that so a mainly constructive, it means that there are tons of outputs could be for not 5, it's not a good input, mainly for 8 there could be 3 solutions, I mean 3 outputs if I don't miss. Print a beautiful permutation of integers. If there are several solutions, you may print any of them. And often an output or just and conjunction, it says if there are several solutions, you may print any of them or print the minimum or print the maximum one. And at the else point, just no solution. First, I want to know no solutions, like mainly when you solve some competitive programming task and it has two conditions mainly as there. I mean, problem if it has yes and if it has no, and it's possible that for the yes there also something extra, like making this a permutation. You may just first find the no solution, how it happens, how it could be, why it's no, and this, and then you could go for the yes. Because if you start from yes, it would be really hard to understand the no conjunction. Because of, like, this is my advice, you could do as you want, but okay, I'm going to start with no. So with no, when I was solving this task, I just took, like, if it's if n is small, then it is no solution. For example, there 3 for 3 I could do. For 2 I cannot. For 3 I cannot. For 1, for 1 it's normal. Let's check just. When I give 1, it's just 1, and it doesn't have anything. For 2, if I give even 1 or 2 or 2 or 1, like the absolute value, like they're adjacent and there's the same, I couldn't. And for 3, what's some solution, like 1 2 3, doesn't work. 3 2 1, it's pretty hard. 3 1 2, I see. No, it's no. Also, let's get started by 4. 3 1 4 2. It's good. Okay. And I think so. There's going to be like this. If n is equal to the 2 or just 3. Here it is. And the second one, mainly yes. Okay, when I was solving this task, it was really so hard. First, as you see, This man put even even numbers to other side and odd numbers to the other side, because when we take two even or odd adjacent elements, their difference is minimum 2, like 1 3 or 9 11, yep, or like 7 8, like this, 11 13, as you already noticed. And also with even 2 4 or just 4 8, like the same, yep. Because of this, I think so you're just going to do like this. And mainly, as you see, it firstly it gave even and next odd. And when I was solving this type task, mainly I split it to the two solutions. If n is even and if n is odd. If it's odd, firstly I was printing even and then odd, and with the even types, firstly odd and then even. But mainly, as you see, it's easy just to print even and then odd, and that's all. You don't need to split them. It's easily understandable. Okay, so let's go right there. And yeah, 5. Let's do it like this. So we're given some n. Then we need to make some vector. This let's I think so it's better to push back. For example, for let's do even. Yep, it's 0. Doing 0 with a it. I don't think so. Yep, it's impossible. So 2 y is less than n. There could be some problems, like if n is 6, no, it's good. For example, if n is 9, it could go to the 10. Okay, we will see. So there I like just to push back y. That's on. Yep. And then the odd one, holy crap, I missed. I think so. No, I haven't missed. I don't need to divide this too. Y 1, then it's less than n. And then I like just to push back also y. Let's just copy this. It's going to be easier. So, and then we just output this. Some addicted to size t. Y is less than n, yup. No, n dot size. But we could also give n. I think so. AE. Let's compile our file. Run. Yeah. I think that's good. Nope, it's not good. Mainly, yeah, I made crucial mistake there. And the same right there. Okay. Why? I have question. Let's think. What delete this? 5. Okay. We get runtime error, and it's holy crap. This, what the hell I'm doing, bro? Yo, oh my goodness. Okay, yeah, it wasn't that much crucial. I just type of joke. Okay, I'm cheating, so yep. I was expecting this. For example, if I do like this. Okay, let's give 8. For 8, it's going to look like this. For example, 8. 8 for 2. No. I start from 2. 2, 4, then 8, and also there needs to be 1, 3, 5, 8. Oh, 7. I missed. So I forgot about 6. Yeah, it's pretty good. So yep. Okay. Yeah, I gained this. So let's clear. It's incredible. So there, I forgot about no. No solution. If n is equal to 2 or n equal to 3, print no solution. Return. Why? Okay, we get syntax error. Oh my crap, I missed. Okay. Yeah, it's pretty good. So let's submit our task. Yeah, it's accepted. Good point, good point. Fifth task, number spiral, tokenites, two sets, bit strings, trailing zeros, coin piles. Oh yeah, there are tons of them. For example, I've ever scared about number spiral. Like, I have never got the solution for this one. I don't know how hard it is, but yeah, this is pretty hard to solve. I've never got the sense there. For example, 1, 2, 3, 4, 5. It goes like this, and there it is going like this. Then it's going where? Like if it goes like this, yep. This, like this. How do I see like this, then this, then this, then this? Like it increases every time. Yep. So okay. Yeah, there are also lots of tasks. I also afraid about apartment. It's really easy task, but okay. Let's try to solve this in 20 minutes. Oh, the stream is always going for 40 minutes. Yep, this is nasty. So when it's going to be 1 hour, I'm just going to give up and to watch its tutorial. Okay, so I'm also afraid. I think so. We need to firstly find the maximum or minimum. Then we need to do some manipulation. It's also possible, like, to do this by distance. From 2 and 3, I get 8. No, I couldn't make this. No, this is useless. I mean, note table. There I get 8. Is this good? I don't think so. 1 and 1. Can we get 4 and 2? I think so. It says to us, are you kidding me? No. Okay. So how do I know? It could give some function. Nope. Nope. Yep. So okay. It looks like this. Just the yep, okay, and oh my goodness. Are you joking me, man? I'm not going to copyright this. Yo, no. It would be easier just to skip this task. No, for example, stay right there. It's possible that I will be needed for 2 knives. Or yeah, I know that this is math, so it has some math solution, some math formula, and it also has some greedy algorithm. And yep, your test to count for k. Yep, the number of ways 2 knives can be placed. Oh no, never. I hate this, man. No. So okay, it's just some combinatorics. Mainly, firstly find the count of the 2 knives could be replaced usually, and then find the count of ways how to put them that they attack each other, and then we find the difference of them. So that's all. But I don't know combinatorics. You have also 2 sets. Oh, that's boring. Oh, I also know how to solve this task. I already understand. It says they kill some. I remember I was solving again this type task. The CSES mainly is about some template tasks that you frequently will see because of how I advise you to do. Bit strings. Okay, trailing zeros. Okay, I think so. Firstly, yeah, to try the by number of solvers. Okay, let's go for bit strings. There's 2 at the power of n. Okay. Oh, we need to make our own long for function. Doing it this at mode layup. Yep, that's sure. And 1 year 9 plus okay, so let's just easily make some answers equal to 1. Then oh wait, while b is larger than 0, and as you know, when we divide the how do I know it's space and it's like the power, you divide the power to the 2, automatically the base have its square, mainly it could be it could increase, and also we put right there modulo or something like this. Yeah, so then possibly I'm gonna use this answer skill for no, and also modulo. And how do I know? There, B needs to be odd. Something like this. Okay, and now we are given n. Yep. Let's give some default value. Let's make answer variable. It's going to be equal for power of 2 and n, and then just printing it. It was the same. Okay, so wait, the 16th. Oh, this is strange. It's good. So in function long int power. Yeah, it's good. What's oh, I don't return anything. I think it's because of this. Eight. Okay. Let's say just. Yeah, let's go. Okay, let's also solve two sets problem. Oh, there's also no solution. I think this is also a constructive algorithm. Oh, nope. Okay, once I solved this task, like the same, and it was from CSES, but it was at VJudge. I don't remember my solution, but I just was putting, I was just putting some minimum, maximum, minimum, maximum. Okay, so yeah, it was repeating like this. There, oh, wait a minute. I'm done. So there's minimum, then there is maximum. Then there's maximum and there's minimum. Holy crap. I'm done. So wait. It divided oh 4 gap. Okay. Wait, what is going on? Oh my gosh. Okay, so yeah, it's like permutation from 1 to 7. Okay, let's solve this. So we are given n, there's n equal for 7, yeah. And the permutation looks like this: 2, 3, 4, 6, 10, 7. And my arise is this. There's 1, there's 7, there's 6, there's what? 2? Yep. Oh, like 2 pointers. Yeah, there's 2 pointers. Then 3 is there. Oh, so 3, then 4, no, 5, and there's what? 4. It's bad. I don't know why, but I feel it's bad. No, yeah, it's incredible. So how do I know? There's also some part 1 we divided to 2. Like when in is even there's some another world. Uh, the permutation is 1, 2, 3, 4, 5, then 6, then 7. Okay, so yeah, okay. The first array, 1, 8. Yup. There's 7. There's 2. There's 3. There's 6. There's 5 and there's 4. Let's go. So let's calculate. 20, 8, 11. 11 plus 5 is 4. Wait. Uh, this is 8. This is 11. This is 16. And 8 plus 2, 10, 16. 16, 16. And whenever I give 4 there or there, it's done. And yep. What if I just change there's 8, there's 2, like there's a maximum set another way. Wait, let's check this out, but I don't think so it's really that much good. It's not changing anything. There's 8, there's 1, there's the same, yeah, there's 2, there's 7, yeah, it goes the same, it's just useless to do. Okay, what's the sum of elements from 1 to 8? It is 8 multiply 9, 72, 36. Pretty strange, like it's divisible to 2. Okay, what about 7? 7 multiply 8 is 56, 56 divided to 8. Oh, divided to 2 is... Yo, this is useless to check. Because whenever whenever I get the when I do n plus 1, I get the even number, and multiplying the even number, it means that I will get even answer. And as I go with what? Yep, I'm gonna go with, and whenever if n is even, I get the same, because if it's useless to check, we could just check for what, like for, wait, is it working for 10? Okay. One, 10, 9, there's 2. Only crap. 2, then we go right there. 1, 9, 10, 2, and also, for example, like, we get there, holy crap, there's 3. Wait, this goes, this goes, this. 3, 8, then 4, 7, no, 7, 4. Yeah, 7, 4, then 5, 6. That's all. Yo. It's really like 1, 10, 9, 2, 3, 8, and there's 4, 7, then 5, 6. That's all. Yep. Okay, so we get there 10, and there's also 10, 20, 30, 20, 25. Holy crap. Then we get 25, and there we get 30. Yeah, the same repeats with 5. How would I see this even? We couldn't work. Okay, I feel a sense right now. And for doing this task, I think so. I need just to think about some of only odd numbers. Yep. What about odd numbers? Yo, what was that? Then there's 3. There's 4. 1, 6, 5, 2, 3, 4. 12, 6. Yeah, the same. So I couldn't work with even. Okay, let's check. So it means we solved this. Earlier I said that yo, I couldn't go to the right. Okay, each problem divides to two sides. It is like this. No, and there's yes. We solved this, and I'm really glad. Oh, but I don't think so. We solved it clearly. For example, for 3, we couldn't do. That's all. Yes. Mainly no. Yet no when n is divisible to 2, and or like n is smaller or equal to this 3. That's all. Finally, I solved this. Finally, I solved the 50% of task. Okay, let's move on. Yes. 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 No. So yeah, the tactic is the same. It was funny. So okay. We push minimum, then we push maximum. That's all. So mainly its implementation looks like this. For 1 second, it's going to be like this. Yep, I think so. It's solution. Like, yo, I saw this really strange. Okay, I'm going to show my old code. It's something poor. Okay, so let's put it like this. Yo, I just made everything so bad. Man, my OBS just fell. My OBS is just blowing my mind. Like, yo, I'm already tired. Okay, yeah, that's incredible. Okay, so it took me 117 sets of code. I did this really so bad. First, I check for no and wait, it was really working. Then I started by push. Yeah, firstly, even old filling, I don't know what does mean, but okay. If n is divisible to 2, then change. Yeah, first there was minimum, there was maximum, there's minimum. I was changing their value, then I was changing the order. Um, I did this so bad. And the right now solution is way optimized. I'm not glad to write its code. Mainly let's submit this one. Yep. Its way would be easier just. Yep. Okay. Two lines or something like this. Okay, we're also with strings. What's there also? Wait, I've skipped this. Okay. Yo, you're just to calculate the number of trailing zeros in the factorial. Okay. For example, wait. I just need to find the types that makes 10, like 5 multiplied by 2 or like 2 multiplied by 15, like something like this that makes divisible, that's divisible to 10. But how could I count this? Let's just take input first. Okay, so first I take input right there. Let's unlock the AI. Competitive programming with AI is the most, is the most freaking combo you could do ever. So yep. Just don't use some AI at starting. That's all we'd like to say. Okay, so let's move on right there and ls in n for no. Wait. It's really hard, but it's also interesting. For example, I like to say like as we see, we just need some of fives. Only fives is most important because when we know like before some element that's divisible to 5, like for example 25, there's factorial 24. Yep. And also factorial of 25. At 25 there's going to be 5, and at the factorial of 24 there's going to be 2. Like 2 multiplied to 5 is 10, and because of once 25th factorial we get new 0 if I don't miss. And cause of I don't know what to do. Like yo oh, I see. Yeah, I understood. Yeah, I feel understood. For example, we just need to count the the 5 in the number from y to from 1 to n. Like, this. As you see at 20, yep. Again means like, wait a minute, for example, from 1 to 20. Yeah, I meet 1, I meet 2, I meet 3, I meet 4, I meet 5, and so on. dynamic 10, dynamic what? I go and I meet 15, and after I meet 20, and there's 1 5, there's 2 5, there's 3 5s, there's 4 5s. Wait. No. I mean some multiples. How many 5s in 5? There's 1, but I mean 1. There's also 1. There's also 1. Mainly, I mean just the factorization. What's factorization? I don't remember. No. What is factorization? Yep. Okay. So I was there, but there's also 1. If I plus them, I get 4. Yep. Like I mean 5 multiplied to something, like 5 multiply 1, 5 multiply 2, 5 multiply 3, 5 multiply 4, 5 multiply 5. I get 2. That's all that I was meaning. I'm just 5 and power x, and answer is equal, oh my goodness, to x. No, this x, that's all. And I'm going to make some loop from 5 to this element. If it's divisible to 5, I'm going to find the 5 and how many fifths in this. Okay, so let's do a little, oh my goodness, I'm done. I'm really tired of this, but okay, let's do like 4. It's less than, no, wait, let's see up. Let's do answer variable. So what's the maximum we could get? 1. Okay, so let's do it from 0. No, from 1. It's going to be on. And okay, so mainly to find how many 5 in y, how could I do this? Example, let's go. So wait a minute. So mainly it's going to be as this. No, oh crap. I am in this. So mainly just How do I know? It's something that's really strange, like um, while I started on 0. Mm, it's like this. While y is larger than 0, do this. No, let's like this. X, let's go to 1, and while x is less than or equal to y, and also let's make some. Oh no, answer is there. I do x multiplied to 5, and answer plus plus. Then print this answer. Yo, like 5, it's 1. In 10, it's 1. In 15, it's 1. In 20, it's 1. In 25, it's 2. Could be possible, like how many times x is x could be divided to 5. No, this couldn't be even, like, I don't believe this. But it could be like, holy crap, so many examples. Oh yeah, I remember this, like, wait a minute. I remember that I assumed this the same as n divided to 5, then plus n divided to 10. No, 25, yup. Then plus under all by other one, then n and 1 this. So yeah, okay, I see this. I see my, so there is going to be, what the hell? I'm done. So oh my goodness. So I really don't know how to implement this, like how to really implement this. I make some x is equal to 5, and each time I make it square, like multiplied 5, and then I divide this to n, and I do answer plus plus. Okay, let's delete this. Let's delete this all. But I also will need this. While n is larger than 0, there is going to be some x. Then n multiplied to the x, x, and do like this. Yeah, that's all. It's 2. Um, oh my goodness, why? So mainly like, I'm, and wait, yo, for example, I divide this in, I divide to 5, and that is done. Um, but I need at the total. Okay, I'll remember this loop. Yeah, that's a good point. So, I think it's going to be like this. Uh, oh, wait a minute. I don't believe this. Okay, so, oh yeah, I missed right there. Why? Because, yep, because of this. The main thing I want to say, um, I'm, I'm really done, because, like, how to implement this in C++. For example, what's the maximum? There's and at the yo, this is 5 at the power for all the crap. No, 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 no. So I think so it's going to be easier to adjust. Like it means n divided to 5 plus n divided to 25 plus n divided to 1 implement. I don't know how to implement this, like yo, are you just kind of wait, what? Why do you just do count plus n? Yeah, I see why. Okay, for example, I think it's going to be better. Let's go paste it right there. Yeah, so I was right that how many 5s in there, but I wasn't knowing how to implement this. Okay, right now no. Um, let's move on next task. It's number spiral. Also, we have coin piles. Also, we have two coins. The entire files, a gray code creating strings. This stream is going for 1 minute and 20 minutes. Okay, I think that it would be incredible if I find some code for this task. I think it's enough is CSES. Let's find some shift tracker. So where is problems, which is expert type task. Okay, that's good. Wait. OGCD. What is this? It looks so easy. Wait a minute. What am I looking at? Yeah, I see this task. This is freaking interesting. So I think so. It's really interesting and mainly it's hard. It's a little bit basic task of number theory. Okay, so we will be just taking some elements as an a e plus and that's how we apply. So bj we are going to post integers and oh my goodness. Okay, so let's solve this task by easy way. I think okay, so send this x oh my god, I'm more retarded with this. So mainly I think so it will be easy task. Okay, let's put it like this. Wait, I really could write? This is useless. Okay, so point formally, it says me to print m integers. This is n and m. This is array A, this is array B, and I need to print m integers, and this m integers is the GCD of AE plus BJ plus 1, BJ plus 2, BJ plus 4, like something like this. Yep. So because of there's m integers, yep. So then with this AE, I do GCD with them, and it continues. As the answer I get, oh, I don't get some 1, it's cool. Yeah, I said, okay, I missed. So, nope, so it looks like this. I have BJ up, for example this, and each of them I plus this. This one is going to be there, 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 and then I find the GCD of them. Mainly the limits. What's the limits? Oh, I think so. First, this is normal, but no. To find GCD, there's some recursion, or we will be needed some loop because of it's not a good choice. So, from by my knowledge, from number theory, I would like to do this task, like this. Wait a minute. Okay. Okay, let's go like this. So, the GCD is just, I think so. It's now just once to plus BJ, like AE, A1 plus BJ, and then it's enough. Like, yeah. It's enough to do like this. Okay, so and then it goes until AN. I find it this and it's GCD and that's all. What's the time limit? I hope 2 seconds. It's a little bit small. So I would like just to think about also way optimized solution. Okay, so yeah, so okay, I think so. This is the end of the video. It's possible that for the next video will be audio test from CSES. Also, it's possible that we will do from Project Dealer. So goodbye. See you later.